Hello and welcome to the DevOps conference here in Munich. I'm glad to join you to speak in the next 60 minutes about a topic that is very near to my heart. It's about containers, especially Docker containers in the Microsoft world. We are not only going to talk about containers on Windows. Of course, containers on Windows are an important topic. People can still come in, that's perfectly fine. But we are also talking about what Microsoft generally does in terms of containers on premises and, of course, in the Azure cloud. Let me quickly introduce myself before we go into further details concerning the containers in the Microsoft world topic. My name is Stropek. I come from Austria, from a beautiful town which is called Linz, so not that far away from here. I have my own little company which is called Software Architects, and we are specializing on cloud computing. We do cloud computing. We have been doing cloud computing for nearly 10 years now. So our company is really born in the cloud. We run our own software as a service solutions, and we help small, medium and large customers to succeed in building cloud solutions for software as a service, for doing the transition from on-premises license-based model to a software as a service model, especially in the Azure cloud. As I'm doing quite a lot of work together with Microsoft and based on Microsoft technology, I'm a little bit proud that I'm an MVP for Microsoft Azure, Microsoft Developer Technologies, and a Microsoft Regional Director. That does not mean I'm on the payroll of Microsoft. I have my own company, but that just says that I'm doing a lot of work with the Microsoft community, and I hope I can answer all your questions about containers in the Microsoft world today. Of course, you will get my slides. The session is also recorded, so you can take a look at it afterwards. If something is too fast or if you want to discuss it with some colleagues, take a look at the video. It will be published by the conference organizers. Feel free to link yourself up via LinkedIn, Xing, or any other social media platform. I'm more than happy to link me up with you. And with that, let's go into the details. What are we going to discuss in the following 60 minutes? First, why? Of course, why are containers relevant in the Microsoft world? What does Microsoft has to do with something like Linux? Why do we need containers on Windows? They work well on Linux. Why do we need them? We already have Hyper-V, so why do we need containers on the Windows world? The next, I'm going to speak a lot about the different options that you have if you want to run a container-based workload, either on premises or in the Azure cloud. I'm going to show you how you can run it on your dev machines, how you can run it on your Windows servers, on your Linux servers in the Azure cloud, and what platform as a service, managed services, Microsoft offers you in their Azure cloud services. And last but not least, I have a few slides, and I will use some slides here, but I also have a lot of demos, and let's see how many of them will work. Of course, I always need internet and things like that. Let's see how long the hotel wireless LAN will work, and the demo gods are smiling. Please come in, join us. We have a lot of free seats. Let's start with a quick overview. Let me quickly ask you, if I speak in that loudness, do you understand me in the back? Because we don't have loudspeakers. Okay, very good. Let's start with a quick overview about options and tools. First, Microsoft has fallen in love with Linux and containers. What I mean with that is Microsoft has drastically changed over the course of the last years. There has been times, ancient times, when Microsoft, let's put it that way, wasn't that friendly when it came to Linux. Today, the thing has turned completely. Really a lot of virtual machines in the Azure cloud are running Linux. Microsoft is delivering most of their most prominent developer products, database systems, and so on Linux, on macOS, and on Windows. So if we are talking about containers and Microsoft, the time when we were talking just about Windows is long gone. So that's one point that I wanted to make very clear at the very beginning. So, let's say a child of this love between Linux and Microsoft was a close coordinated effort between Microsoft and Docker Inc. to make Docker run perfectly well on Windows. And that's the first thing that I want to make clear here. Microsoft didn't fork the Docker client, the CLI and things like that, but they actively worked together with Docker Inc. and they contributed to the open source project. And with that, you can now use the plain Docker CLI to connect to Linux Docker hosts and to Windows Docker hosts. You don't need to any special API or tool. Let me quickly demo that for you. If I start a command prompt, then I have my Docker exe here. And if I say Docker info, you will see that in that case, I'm currently talking to an Alpine Linux, which runs on a virtual machine on my laptop. I will show it to you in a second. And I can talk to this Alpine Linux. But of course, I also have my bash shell here on Windows, and I can use exactly the same executable. And this executable, this Docker CLI, is built from the same source code as on Windows. So you really have exactly the same tools, independent of whether you run them from Linux or Windows. Yes, you can manage your Windows containers from a Linux bash with the Linux Docker CLI. Okay, that's a very important thing. Question?
What is bash or is this bash thing?
What this is, I will cover that in a second. Give me a minute. So the first thing, the Docker client on Windows runs perfectly well. The next thing is Linux containers on Windows. What is Linux containers on Windows? It's a coordinated effort between Docker Inc. and Windows and the Windows team to give you the nice little Docker whale directly on your Windows 10 box. If you want to run Linux-based containers on your Windows 10 developer machine, because you do some Node.js, Python, .NET Core, whatever development which will result in executables for Linux, install Docker for Windows, and that gives you this nice little Docker whale here. This Docker whale will also give you, in Hyper-V, a virtual machine. It's an Alpine Linux, and this was the virtual machine that I connected to a few seconds ago. Okay, it will give you a virtual machine with a specialized Alpine Linux with a Docker host running inside of that virtual machine. You don't have to care about setting up this virtual machine. This is all done by Docker for Windows. Docker for Windows, when you install it, it will create this VM, it will set up this VM, and Docker for Windows will also maintain this VM. You don't have to care for it. It just runs and it works and it plugs in nicely into all the things that you know from Hyper-V on Windows 10. So this is a good thing for developers in the room. Question? Okay.
There was always a blocking thing in between, and I searched the whole internet.
Yeah.
It was far away from being convenient.
Okay. On my laptop, and I do a lot of trainings for Dockers, it works perfectly well. I sometimes, in rare situations, especially in enterprises with very strict firewall and domain policies, ran into that problem, and we had to debug it on a case-by-case basis. But I can assure you that in general, it works perfectly fine and without any problem. We run it on dozens of machines, and I ran it on, I think, hundreds of training environments, and it really worked. In some very rare cases, it wasn't the case. I'm sorry for you, but we would have to debug it on a case-by-case basis. So in general, it really works quite nicely. So this is Docker for Windows. And the nice thing of Docker for Windows is that they also integrate support for Windows containers. I will not click on this menu item here because I have some demos for which I need the Linux support, and if I now switch, my demos will all break and so on. I will show you Windows containers in a virtual machine in a second. But if you are a developer on your Windows 10 machine and sometimes you develop Linux containers, use Docker for Windows. And if you have to run, I don't know, .NET full framework application where you need a Windows container, it's just one click away. I could click it, and on my machine, it's not that old Dell XPS, it takes approximately 10 to 15 seconds. And if I then say Docker info, it would say, hey, you are now talking to Docker on Windows, and you are talking to a Windows 10 developer machine. Okay? So this is very nice, and I can really encourage you to install Docker for Windows. It works perfectly well for a developer scenario. That's not targeted for production development, okay? For production operation of applications. This is just for development purposes. If you want to run Windows containers, not Linux containers, I already mentioned that it works on Windows 10. But of course, it also works on the Windows Server. Let me quickly switch to a virtual machine that I'm running here I have to turn up the fonts a little bit. Let me see. Let's take that one. I hope you can see it now. Can you read it from the back? Is that okay? Okay. So if I now say Docker info here, as I mentioned, this is just a plain old Docker CLI. I'm now talking to a Windows Server 2016 Data Center Edition. So now my Docker host is no longer Docker running on Linux, but it's Windows Server. The Windows Server now knows how to speak Docker protocol. Okay? No additional things needed. You just switch on the Docker service for Windows. It's a standard Windows service starting from Windows Server 2016, and it just runs. Okay, so I can say things like Docker images, and in that case, I'm not going to see things like Ubuntu and things like that, but I'm going to see, for instance, Windows Server Core. I will show you a demo in a second how we can work with these things. Next one. Microsoft does not only support Docker hosts on Linux and Windows, but they also work very, very heavily on contributing images on the Docker Hub to make it easier for you to run server workloads or to build software with Microsoft-related developer technologies, in particular .NET and .NET Core. Let me give you some examples. Let's start with .NET Core. If I click on .NET Core here, hopefully the link will bring me to the Docker Hub, and you see that Microsoft provides Linux and Windows images for running .NET Core application. So the beautiful thing here is that you don't have to care about how to install .NET Core on Linux, Debian in particular, or on Windows. The images are already there. You just run them and you use them to run your production workloads, or you use them for your CI/CD scenarios. You don't have to care for the Docker files for building the images. It's just there. But Microsoft didn't stop with .NET Core. They added a lot of things. For instance, if you want to interact on the command line with Azure, you have the old Azure CLI and you have the new Azure CLI, depending on which CLI you want to use. There has been a major version a few months ago, so you can pick and choose ready-made images and you don't have to install the Azure CLI yourself. You can also, for instance, use PowerShell. If you want to automate things in PowerShell, feel free to grab this one, Microsoft/PowerShell. And the important thing is that Microsoft does not only support PowerShell on Windows, but also PowerShell on Linux. So PowerShell is now open source and cross-platform. So you can use PowerShell on Linux with a ready-made image from Microsoft. It's up to you. It's already in the Docker Hub. If you want to run a web application on the Windows Server, you get a ready-made image with Windows Server Core and Internet Information Server. So if you have, for instance, a rather legacy old .NET 3.6 ASP.NET application, you can now run it inside a Windows container, and you don't have to care for how to install IIS, set it up, how to set up ASP.NET and things like that. All these things are already in the Docker Hub. You might question yourself, well, how do I find all these images? Well, just go in the Docker Hub, and if you don't misspell it like I do, you can just take a look around. They are all named Microsoft/something, and you will find all the official images, Windows and Linux, that you can use for development and for production. Okay? Licensing, I'm not a licensing expert. I live and breathe in the Azure cloud, and there I just pay for the VMs or PaaS services, and That's it. But there is a special license agreement for containers, and I would ask you to take a look at it. I was told that it is quite similar to Hyper-V, but please take a look at it. If you want to, let's say a concrete example, if you want to run SQL Server, the Express Edition, on a Windows container, the Express Edition is free. But if you want to run a Data Center Edition, the Enterprise Edition or the Standard Edition, of course you have to bring a license. The same is true for Linux. SQL Server is now supported on Linux. A ready-made container is already there. So if you run a production workload on SQL Server on Linux inside of a Docker container, you have to care for the proper licensing. I'm not a licensing expert. Licensing and Microsoft, that's a huge area, and I don't want to get into that. Now comes the next large topic, and we will see some demos in the upcoming 45 minutes or so. Containers on Azure. Of course, the container story of Microsoft starts and is targeted primarily at cloud scenarios. Okay? Microsoft is now a cloud company. The motto is cloud first, and in parts even cloud only. So they optimize all their container story first on cloud scenarios. If you take a look at Nano Server, for instance, the smallest SKU that you can take and use for Windows, it's optimized for the cloud. If you take a look at the container workload inside of the Windows kernel, it's optimized for the cloud. Okay? And Microsoft really invests a lot to make Azure the #1 platform for running Docker containers, of course. If you decide that you don't want to follow this strategy and you want to run your containers in your own data center, of course you can. But then you have to care for the infrastructure, for the hypervisor, for maintaining the operating system where your Docker cluster runs and things like that. Then it's up to you. But Microsoft takes it one step further if you are in Azure and gives you a lot of managed services. Let's quickly take a look at what Microsoft offers you if you want to follow them in the Azure cloud. First, you have so-called ARM templates. That are essentially templates with operating systems with Docker installed. So, for instance, if I click here, that will take me to a GitHub repository where I get a ready-made template. ARM template is just a JSON file describing PaaS and IaaS resources that can be deployed to Azure with a single click. And there is a ready-made template for running an Ubuntu server with Docker installed. Generally, Microsoft has created a ready-made plugin that you can plug into any Linux service that you run in Azure, and it will bootstrap Docker inside of this Linux virtual machine, and all these things are ARM compatible. So if you need Docker on a standalone server in Azure on Linux, you just add an extension. You'd say, give me the Docker extension, and it will install it, and that's it. But to make this thing very clear, this is infrastructure as a service. You have this Tamagotchi in the cloud. You have to pet it and feed it and update it and keep it running. That's infrastructure as a service. If you want to do that, perfectly fine. You are in control, but it's your control, okay? That's the whole ARM template stuff. If you want to go with the Docker products, Docker machine, Docker cloud, and so on, Docker and Microsoft are good friends, and you get a lot of drivers. So if you use, for instance, Docker machine to set up Docker servers from the command line, you can do that, and you get an Azure driver that is just plugged into your Docker server. So you can say, hey, give me a new Docker host, and it should run in Azure, and it will do all the necessary deployments in Azure for you. Okay? And you can use the Docker tools to keep them up to date, if you want. Now we come to the areas where it's getting really interesting, in my opinion. Containers as a service. I personally run a small shop. We are not a large team. We are 6 people. 5 of them are technicians. 4 of them are mainly developers. We have no admins at all. We run more than 100 database clusters. We run dozens of web farms, dynamically, elastically scaling. We could not do that if we would use infrastructure as a service. We bet the farm on managed services and platform as a service, and therefore it's very interesting for me to see that Microsoft has started to deliver container as a service. So what you can do is you can use a service which is called Container Instances, and I will demo them in a few minutes. And Container Instances are single container or multi-container solutions, and Microsoft cares for running the underpinnings, for running the virtual machines, for keeping the operating system up to date, for maintaining Docker, for keeping it high availability, for doing all the networking stuff. They care for running these things. And you pay what you really use based on a combination of CPU and memory. So you can just say, give me a container running this image with 2 cores and, I don't know, 1.5 gigs of RAM. And you will pay for the cores and the gigs of RAM per second. If you run it for 20 seconds, you pay 20 seconds. And you don't care for the infrastructure. Okay? That's Container Instances. And we will go into more details here. App Services. App Services is a specialized service from Microsoft for running web workload. Do you want to run a web API? Or do you want to run a web app or a WebSocket thing, a microservice, speaking HTTP or WebSockets? Then App Service is your friend. This is a platform as a service solution, fully managed. You cannot access the underlying servers. They have all the things that you expect from a professional web solution. Things like reverse proxying, auto-scaling, things like monitoring, plugging into application insights, and things like that. Support for SSL, custom domain names. All these things are built in, but you don't care about the services, the networking infrastructures, the reverse proxies, the DNS infrastructure. It's all managed by Microsoft. But this is only, to make this very clear, for web workload. You cannot run you cannot run a SQL server in there. If you want to run a SQL server platform as a service, you go for Container Instances. This is for the web workload only, specialized. Next step. Azure has a product which is called Azure Container Services, and it comes in 2 flavors. Azure Container Services, as it has been a few months ago, was a bootstrapping solution for you to get up and running with DCOS, Kubernetes, or Docker Swarm. You don't have to do the necessary things to create the VMs, to set up the networking, to do all the things, to do all the install work, to configure the operating system. It was a template, essentially, to get you up and running with these 3 orchestrating engines in Azure within minutes. But then it was up to you. And now, only a few weeks ago, Microsoft announced an addition to Azure Container Services, and that is AKS. It's Kubernetes. It's managed Kubernetes. So you get Kubernetes in Azure fully managed. They manage your master. They do the security patching on all the workers. You have the possibility to upgrade from one version of Kubernetes to the next one just by clicking a single button in the Azure portal, and they manage the entire Kubernetes infrastructure for you. But be aware, this is preview, this is early preview. I would even say it's experimental, so don't expect it to be ready for production workload. Don't use it for production workload. Use it if you want to play with it today. Use it only in the US. It is theoretically supported in EU too, but there are some gotchas there. So it is an early preview. It will take some additional weeks or months until this thing hits general availability. But this is the way Microsoft is heading. Managed Kubernetes as one orchestrator that is fully platform as a service, and you just take your images, develop it, as I said, on your machines, and push it to your Kubernetes cluster, and this thing is just running in the cloud. And the beautiful thing here is it's free. You just pay for the underlying infrastructure. The whole platform as a service offering is free. You don't pay anything for Microsoft doing the necessary management. The next thing that is also platform as a service. Yep, question.
Will Microsoft also invest in the Kubernetes development?
Oh, Oh yes, the question is, does Microsoft invest into open source projects like Docker, Kubernetes and so on? The answer is oh yes. They do a lot of investment and they have hired some, let's put it that way, some very experienced Kubernetes experts which used to work for Google. They now work for Microsoft and they invest a lot. The bold goal that was announced at a conference a few weeks ago is that Microsoft wants Azure to become the #1 platform for running Kubernetes. And that's a very bold statement given that Kubernetes and Google are very strong today. Okay, so they are investing heavily to reach that goal. Okay, and this is the road that Microsoft is primarily heading when it comes to orchestrating complex container infrastructures. The nice thing is that the container instances that you see up here, they have an experimental feature with which you can plug in the container instances into a managed or unmanaged Kubernetes cluster. That means you can create a bunch of VMs for your Kubernetes cluster, but you don't have to. You can keep your Kubernetes cluster quite small and tell the Kubernetes cluster that it can pick and choose additional containers from Azure Container Instances. And there you pay per second. So you have a small container that is large enough to cover your stable, necessary infrastructure. And then you plug in, let's say, a kind of burst mode where you say, if you need more, take the container instances, spin them up as you need them, and you pay per second for this, let's say, performance bursts. Okay? That's the strategy where Microsoft is heading to. It's not just VMs where you pay for this huge cluster and only use a fraction of it. This is experimental feature. Again, it will take some additional months until you can do that in production, but you can try it already. It's out in the wild, you can try it on Azure. The next platform as a service is the Azure Container Registry. The Azure Container Registry is a Docker registry maintained by Microsoft, run by Microsoft in the Azure data centers. So it's a private registry that you can run in your Azure subscription and that you can put from a networking perspective near to your Docker hosts or Docker clusters. That means your container registry and your Docker cluster are sitting side by side in an Azure data center with a very strong network connection. Okay? And of course, these things support things like geo-replication. You can say, I have a container registry in Western Europe and I need exactly the same images in the US. Please, Microsoft, do all the necessary replication for me. I don't want to care for it. I push it to Europe and it is auto-replicated to US. All these things are supported by the Azure Container Registry. The Azure Container Registry also plugs into Azure Active Directory. That means you can authenticate with your Azure Active Directory or in general your Active Directory account on the Container Registry. Okay, so you can use the Docker Hub. Of course you can if you want, private or public accounts, but you can also set up a Container Registry and this is fully managed. You cannot access the service, it's just there. Okay, it's maintained and managed by Microsoft. And last but not least, I will not go into details here, there are other very Azure-specific services, Microsoft-specific services. These things are not driven by the community, and they also support today Docker containers. And especially that's Service Fabric, which you might know or might not know. It's, let's say, something like Kubernetes, but a little bit different, the Microsoft way, and it supports container workload now. And there is a batch service in Azure, which is there for running batch workloads, doing some kinds of simulation, Monte Carlo simulations, things like that. And they also support now isolating these batch workloads in containers. Okay? These things are all platform as a service. Service Fabric managed by Microsoft, batch managed by Microsoft. As I said, I will not go into the details here. Any questions concerning the Azure options? We will see, we still have half an hour, so you will see some of these things in action. Okay. What else do we have? Last but not least, I'm primarily a developer, so if we are talking about DevOps, I'm really dev and only a little bit ops. That's why I love PaaS, okay? So as a developer, I love the integration of Docker tools in development tools. Visual Studio 2017 now has full Docker support. So if you are a developer and you develop, for instance, a .NET backend, you can just hit F5, start debugging, and it will dynamically generate the Docker files, the Docker Compose files. It will spin up the container. It will set up remote debugging, and your breakpoint will hit in Visual Studio on your Windows machine, although you are running your application inside a Linux Docker container. And that works in a microservice infrastructure across multiple containers. So if you have a solution in .NET where you have 3 microservices in this solution and you hit F5, it debugs all 3 things in 3 different containers, does the remote debugging and all these things. It's just there. Visual Studio 2017 can do that. It comes out of the box without additional costs. You have VSTS Docker extensions. VSTS is the CI/CD platform of Microsoft, Visual Studio Team Services. Maybe you know TFS, Team Foundation Server. VSTS is the hosted version of TFS. And if I say VSTS Docker extensions, this works in your TFS too. So if you are today running Team Foundation Server for your dev teams, then you can do exactly the same as you can do in the cloud. So you can integrate all your necessary Docker image commands like build image, push image, pull image, start container, stop container, all these things. You can do that inside of TFS build and release management pipelines. And in the cloud, of course, it's fully managed by Microsoft. Microsoft also, for VSTS and TFS, gives you a ready-made Docker image, which I find very convenient, a Docker image with a pre-built build agent. So you can run a build agent that supports things like .NET, .NET Core, Node.js, or whatever you want to have, and it's ready-made image. You just say Docker pull VSTS agent, Docker run VSTS agent, give it a so-called personal access token so that it knows how to find the TFS or VSTS, and then it just registers as a build agent. You don't install any build agent. You don't maintain them. You just pull the image down, run it, and you have a build server inside a Docker container, supported for Windows and Linux. Before we go into the demos, I have one last theory slide, but I think it's very important to talk about that. What are the differences in the implementation of Docker containers on Windows and on Linux? On the Linux side, if we have a continuum from faster, more efficient to more isolated, more secure, we of course have the process isolation. Then we have the Linux containers, which both sit in user mode above the kernel. And then we have on the right-hand side the virtualization stuff, the hypervisors, which really do very strong isolation of machines. You can run Windows on Linux, Linux on Windows. They essentially simulate hardware. That's the Linux stuff. On the Windows stuff, we have exactly the same. We have the process isolation. We have the so-called Windows Server containers, which also sits on top of the Windows kernel. Okay? And we can isolate our workload there. But it turns out that many large customers, and especially also customers inside of Microsoft, weren't happy about Windows Server Container as they are here. They were telling the container and the kernel team that they will not rely on just Windows Server, on just kernel constructs for isolating workloads. They said, hey, if we run that in Azure, we are hacked, or people try to hack us every single second. That's not enough. We need stronger isolation. We need the best of both worlds. We need to be able to run containers on the kernel level for, let's say, trusted things that run inside of our data center, where people deliver images who we trust. And we need to embed these containers inside of Hyper-V, inside of a virtualizer, to have the strong isolation of a virtualizer. And this is why Microsoft built something that is currently not available on Linux, which is called the Hyper-V container. The Hyper-V container does essentially the following. It runs a very small Windows system inside a Hyper-V virtual machine. This has a memory footprint of approximately some dozen megabytes, something like this, 40 megabytes, something like this. And this kernel in there runs then a single container. So every container is embedded in its own virtual machine, and therefore it's also separated with a hypervisor, and therefore it's more secure than just having a kernel construct. Okay? So this is very nice for a non-trusted workload, for maybe a container image from a third-party developer, from an external source that you want to run in your data center, where you want to make absolutely sure that there are no breaches, and where you want to embed this thing inside of a hypervisor. This is the Hyper-V container. The important thing is, it's the same tooling. It's the same images. It's just one option when you say Docker run. If you say Docker run, you can choose embed it in a Hyper-V container or run it natively on the Docker container, on the Windows kernel. Do you get the idea?
Can you run Linux Docker images also in a Hyper-V container?
No. If you want to run Linux containers, you need to have a Linux operating system. If you want to run Windows container, you need to have a Windows operating system. If you want to run Linux containers on Windows, you need a Linux VM in the middle.
So it's already isolated anyway?
Exactly.
Okay.
Yeah. But in that case, maybe I didn't put it clearly enough. Every container is isolated in its own Hyper-V VM. So if you run 20 containers, you have 20 VMs, okay? So not just a single VM running all 20 container images, every container is embedded in its own VM. Microsoft has spent a lot of time optimizing performance here. So don't think that Microsoft boots up Windows from scratch every time you create a Hyper-V container. That isn't done. But they closely analyzed which parts of the kernel, of the kernel's memory, is read-only, and they do essentially a mem copy of large parts of the existing kernel that is already in memory, to be very fast when spinning up new Hyper-V containers. But still, on a typical server that we use, spinning up a Windows server container takes between 600 milliseconds and 1.5 seconds. Spinning up the same in a Hyper-V container takes approximately double the time. So 1.5 seconds to 3 seconds. So it's up to you. You can decide. Question? No, they aren't. No, you don't see them and you will not see them. Well, you see them a little bit. Let me show you a quick demo here, okay? I have prepared a small demo here, and here we are. Let me enlarge the font a little bit. Now we are switching over to the demo part, okay? We have a little bit more than 20 minutes, and now we are going to just do demos and take a look at things in practice. So here is my task manager. And okay, the first thing that I want to show you is I want to run a nano server. Please note that one. A nano server, which is the smallest SKU of Windows that you can currently get, okay? And I run a single process, ping, an endless ping to localhost. But please note that one here, okay? Here you see isolation equals Hyper-V, and that means it will run inside its own virtual machine. So let's see what happens. Take a look at here. We have one VMWPXE. And if we run that guy, it will take, this is a very small VM, so it might take a second or so. But do you already see that new VMWP processes are spinning up? So what we here see is that it's now starting its own virtual machine, and the container is running inside the virtual machine on this mini version of Windows, okay? And on the host where the Windows kernel is running, we only see the worker processes of Hyper-V, but we don't see the ping process, because the ping process is running inside of the virtual machine. Okay? You get the idea? Okay, let's stop this guy. Docker images. Docker PS, that is, nothing is running. And now we are going to run exactly the same, but this time, where is it? Here it is. But this time we are going to run this guy not with isolation Hyper-V. The first thing that you will recognize is that it will be faster. The boot up time will be faster. And if I now take a look, I see, do you see it? Ping.exe. So I'm here on the host and we see exactly what we expect to see. We see the processes of the container running in the host's kernel because the kernel is reused. That's the whole point in containers, isn't it? Okay? It's the same as in Linux. Okay? You see it on the host, not with the Hyper-V stuff. And if to prove the point, please take a look at the ping.exe. If I stop this container, ping goes away, the process is gone and the container is gone. Okay? That's the difference between Hyper-V containers and Windows Server containers. And the beauty of this thing is, you as the ops guys, you have the choice. You can decide. Okay? If you need for one microservice, if you need the isolation, take it. And you can run it side by side with another microservice that just needs performance and you skip the Hyper-V. It's up to you. Question?
That's then a Microsoft-specific switch?
Yes. No. This is Microsoft specific. This is a feature that Microsoft has built into the kernel and the hypervisor on the Windows platform. Okay? This is not something that is operating system agnostic. In general, please don't underestimate the amount of work that Microsoft has put into Windows to make this thing work. This was not something where a few Microsoft guys sat together with the Docker guys and they decided to implement that, and 2 weeks after that they had containers running on Windows. That was a multi-year approach. Microsoft already has done quite a substantial amount of work supporting containers on Windows even before Docker entered the scene. What happened is that in the middle of this development process on the Windows kernel, Docker became public, became very popular. And so they met with the Docker team, and these two teams, they really found together. And they said, okay, so let's think how we can do the most by not implementing two distinct solutions, but work together. Why should we not offer the Docker API, the REST API compatible to Docker on Windows in exactly the same way as people are used to it on the Linux way, okay? But we have substantial changes to the Windows kernel and to the hypervisor, to NTFS drivers, to the network drivers, to all this low-level stuff in order for Windows to support containers. That was not a trivial thing, and it was a substantial amount of work. Many people ask me, hey, why do Microsoft only support that on Windows 10 and Server 2016? I need it on Server 2012 or Windows 7. That is not going to happen, okay? Because of the substantial changes in the Windows kernel. Okay. We had this sample. Let me quickly take a look at what we will do at the next sample. Linux and Windows. Yeah. Linux and Windows. Let me show another sample here. Here we are. And I want to have that one, and I want to have that one. Here it is. This is a Docker file. Let me zoom in a little bit. This is a Docker file for Microsoft.NET Core, okay? It should show how Microsoft.NET, which is a very popular programming platform, supports running on Linux and Docker containers on Linux. What you see here is, well, this is not, if you are not a developer, then this is not really interesting for you. This just does the building of the solution. This is just build, okay? This is just compile the C# code to some kinds of DLLs. We don't go into the details here. We want to take a look at the container stuff around. And what we see here is that we use a ready-made image, the Microsoft.NET SDK image, which comes from Microsoft. So we don't need to set up our own Debian system with .NET installed, with the SDK tools installed, and so on. We just use the image from Microsoft to build the solution. So the CI part, the continuous integration part, is already done in a temporary container here. Okay? The next step here, this is a multi-step build. That means we do the CI part above, and then down here in the Docker file, we say, now we only want to have the runtime. Why is that important? The .NET image, including the SDK, is approximately a gig in disk size. So it also has quite a large memory footprint. The runtime only just contains very few binary prerequisites that you need to run a compiled .NET application. So what we do, the first part compiles the stuff, and the second part copies the build results from the ready-made image into a specific image also provided by Microsoft that is optimized for running your production workload, not for compiling. Okay? So we take the CI pieces, embed it here, and the result will be an image with our web application, in that case a microservice written in .NET Core, baked into the image. Do you get the idea? This Docker file sits on my local Windows 10 machine. So next is a small bash file. And this bash file just copies some files. But the important thing is here, you see I'm just running Docker build directly on my Windows 10 machine, but we are using Linux containers, okay? So I'm using Docker for Windows to build the Linux-based container on my Windows 10 machine. So I'm using Visual Studio Code, all these things on Windows 10, but still building Linux images on my development machine. That's the point here. So we do a plain old build step here, and then we can also do a run step. And I'm not going to go into the details. It just listens on port 5000, and then I'm doing a curl here, and it should just return hello world. The code doesn't matter, okay? It's just a single line in C# code. It says, whatever HTTP request comes in, answer with hello world. So let's take a look at that. I have my terminal here. Let me quickly go into into that guy here. And you were asking a question before. What is this bash thing on Windows? How can I get a bash inside of a Microsoft developer tool or a bash directly in Windows? This has been quite a source of confusion in the last months. A lot of people asking me that. To make one thing very clear, I don't know if all of you know that. The Windows kernel speaks Linux kernel. The Windows kernel is able to answer kernel API requests with a special kernel level driver. Starting with Windows 10, Microsoft has implemented a kernel level driver that emulates Linux kernel on top of Windows kernel without a VM and without containers. So I can run a native Ubuntu and a native bash shell and all the things that you know and love. Your Node.js exe, your, I don't know, .NET compilers, your Docker CLI, all the things native Linux on top of the Windows kernel. Okay? So if I type bash here, what you see here is really a native Ubuntu with a native bash talking to my Windows kernel without VM, without container. That has nothing to do with Docker and has nothing to do with virtual machines. It's just a capability of Windows. Okay? Who knew that? Okay, some of you, maybe a quarter of the room. You can also do very nice things. For instance, if I go here, something like this, you probably know that in any Windows Explorer window, you can just type cmd and you will get a command shell, right? But did you also know that you can type bash and you will get a bash shell and you are in the same directory? Very nice. You can also call calc.exe. Of course, this is not a Linux command, but the Windows driver will recognize that it can't find calc.exe on Linux and it will spin up the Windows command here. Get the idea? So it's really very nicely coupled. Okay? Question? the Linux commands on Windows. It depends. That's always the answer if you are not sure. It depends on what you do. If you have a CPU-bound workload, the overhead will be very low. If you do very much I/O-bound workload, it has to simulate the Linux file system on top of the Windows file system, and that takes a lot of time. So is it faster than Linux? Not, of course not. Is it as fast as PowerShell? Well, it depends on what tools you use. The important thing, why I think this is really interesting, is that you get all the nice things from Bash that you know and love. For instance, if I say Docker images, Microsoft, let's do that one. If I say Docker run, and if I say Microsoft /MS SQL tab, then I get statement completion as you are used to it in Bash. Is that possible in the Windows command shell? No, it isn't. Is it possible in PowerShell? No, it isn't. But it is possible in Bash. And that's the reason why I have dropped PowerShell and CMD entirely. I only use Bash for my complete workload. I build all my stuff on Linux, but speaking directly to Windows. I hope this answers your question. No, it's just an option that you can turn on in Windows 10. Okay? Yeah, programs and features turn on, and that's it. And you can install different flavors of Linux from the Windows Store. So they now have Ubuntu, they have Debian, and many other Linuxes that you can install from the Windows Store, and they will run on the Windows kernel. But again, this was just nice to see, but it has nothing to do with Docker. This was my point. Okay, many people get confused by that. Okay, so let's quickly do that guy here. If I run the build script here, let me see if I'm correct here. Yeah, build. Come on. Okay. And you see, now I'm running my Docker build step inside of my development environment. So I'm using the development environment on Windows, but I'm building and now in a few seconds running a Linux container on my developer machine, but a Linux container running inside this Docker for Windows. So here you see that one, hello world. This hello world is the answer of the Linux container running on my Windows 10 developer machine. So I can build my containers as I'm used to and as I would expect it. Okay? Of course, this is nice, yeah, but in reality, we are not going to do that inside of our development environment. We want continuous integration. We want a professional continuous integration tool. We want a professional continuous development tool. And for that, we can use, as I mentioned, VSTS. Docker is fully integrated into VSTS or TFS. So if you, I've prepared a build script here. It is extremely trivial. I love trivial samples because you can follow them. The point is that we have a build process which gets the sources from Git and then does the necessary building and publishing and so on directly in a build step here. Of course, you can add all the things that you love and use from TFS. You can put a .NET Core build step before it, or you can do some unit testing after it. You can publish the build results. You can publish the test results. All the things that you know from VSTS and TFS build processes. But there is a nice UI integration for CI, continuous integration, and for continuous delivery. So you can do CD steps to publish a newly built result to, for instance, your Kubernetes cluster or your Azure Container Instance. And these things are already there. You don't need to know the scripts. You just have a nice UI here. You see we can enter the name of the Docker file. In that case, it's doing a build image. We can take a look what this thing does. Here you see the action. We can tag images. We can push them to our registry. We can run the image. We can run any arbitrary Docker command. It's nicely integrated into VSTS and TFS. Okay? If I queue this build here, I've prepared that for you. Then we will see, this is running the managed version of the continuous integration from Microsoft here. But the speciality that I have set up for you here, you see that it's doing its job, it's building the image and so on. It's not using a build server in the cloud. What I did before this session, I started the ready-made Microsoft image for the build server on my Windows 10 machine. So it hooked up to my build server in the cloud, made a connection. So what's now happening is the orchestrator of the continuous integration and continuous delivery is running in the cloud. It's running inside of the Microsoft data centers managed by Microsoft. But the build is happening on my machine here. And I didn't have to set up the build agent. It is a ready-made container. So it's running inside a container on my Windows 10 box. Of course, you can run it on your Windows server or your Linux server too. Do you get the idea? Very nice integration, I think. Let's spend the last few minutes in the Azure portal so that I can show you some things here. The first thing that I want to show you is the Azure Container Registry. How difficult is it to get a container registry? You just type registry and you say, give me my private registry. Here it is. You fill in a nice little form, give it a name, decide how large it should be, if you want geo-replication and so on. You click OK, and approximately 30 seconds later, you get that one. This is a private registry running inside your Azure subscription. It's accessible to nobody else but you, and you can use it to push your images into your Azure data center and from there geo-replicate it across the world. And then if you, for instance, want to run a web application, you just point the container as a service to this private registry and it will fetch it from there. And of course that's very fast because the registry and the container infrastructure are sitting side by side on the same data center. Get the idea? Okay. So let me quickly show you that. If I, for instance, want to run, let's put it here, one of my, let's pick that one up. If I want to run one of my web applications that are already in my private registry, let's take a look. It's called AKS.NET Linux SCD. Okay, so if we want to use a PaaS service, web container, and we get here web apps for containers, that is app services running in Azure. And if I want to run this guy, let's give it a name, demo resource group. I can pick that I want to run a new cluster. It should run in West Europe. Let's call it cluster. And I could define a size that I want to use. And then, and here is the important part, if I want to run a container here, I just tell it where to book the image from. Do I want to get it from the public Docker hub or from a private Docker hub? Or do I want to use, and that's the point, my Azure Container Registry. Here I just take my Azure Container Registry, I select the image that I want to run, I select the tag that I want to run, and I can optionally specify a startup file, which I don't need for this image. And I click OK, and that's it. Now, give me a second, DevOps Con Live. Great. And now it will create an app service, which is container as a service. I don't have to create any kind of host, Kubernetes, DCOS, whatever. It will run this thing automatically, pick up the image from my private container registry and run it. Okay? Do you get the idea? So in a few seconds, it should be done. You see the deployment is in process. I would say in 30, 40 seconds, something like this, we are ready to go. And we can use that immediately. This is, as I mentioned, just for web workloads. So if you want to run web APIs, websites, WebSocket things, app services, is really nice. Just build an image with any kind of backend technology, Ruby, Node, Windows, Linux, I don't care. Push it to a registry, Docker Hub or private registry, and point the container as a service services from Azure to the registry and you're done. They already recognize automatically if you push a new image, it will auto-detect that react on the webhook, pull the new image. If you have a cluster with multiple nodes, it will care for keeping it up to date, so it will take down one of them, update one of them, bring it up again, take down the next one, update it automatically, do all the necessary magic with networking, load balancing, and all this thing. So now, pardon? You can do that too. So you can also do so-called staging, where you say, I have a new stage and I want to transmit 20% of the traffic to there and want to monitor these things. Yes, these things are all supported. So now we have our container here, and just to make it very clear, if I go to my cluster that I just created, and if I need more power, that's the beauty of PaaS. I just say, give me 3 servers. Hit save, and let's see how long it takes to scale out the Docker cluster with my microservices in it. It's done. We now have 3 servers with all the necessary reverse proxies and whatever this thing does in the backend. That's the power of PaaS. You can do exactly the same by writing a lot of bash scripts or by setting up your own Kubernetes server, but you don't need to. You have the choice. If you want control, or if you want super high productivity and you are willing to give away a little bit of your control. An hour is so short, but you have seen all the things that I wanted to show you. Let me quickly summarize and finish up. One important message was, Microsoft now loves Linux. You have the choice. You can run Windows containers, you can run Linux containers, you can run it in Hyper-V, without Hyper-V, in Azure, on premises. It's really up to you. Of course, Microsoft invests the most of its attention and money in the Azure scenario. But you can run it on premises if you want, and if you have the necessary DevOps skills. You can use the Microsoft environments for dev and test. I've shown you a dev scenario where I was using Visual Studio Code and .NET Core to develop and build my images on my local machine. And you can use it for production development, for production environments. I've shown you app services in the Azure cloud. I've shown you Windows Server 2016 on a VM for running any kind of Windows containers. So it's really up to you. It's your choice what you do. But I wanted to, with this talk, I wanted to show you that containers really have reached the Microsoft universe. And if you want to run your Windows or Linux workloads, it's ready to go. Right? Nice things are coming around the corner, especially with the Azure PaaS stuff. But a lot of things are already there, and you can start using it today if you want. Thank you very much for coming. I hope it was an interesting hour with a little bit of theory and a little bit of demos. I will be here, and if you have any questions, please come to the front, ask me. I'm more than happy to answer your questions. Thank you very much for coming, and enjoy the rest of DevOps Con.